and twist solids using a single command. I'll start by showing you how to use the move, copy, and rotate command. Looking at our scoop model, note the body move/copy listing in the feature manager. If I roll the feature bar to just below this, you can clearly see that the second cup is merely a copy of the first cup. I then added a scale feature to shrink the cup a bit, and then I connected the cups using various other features. I'll go ahead and edit the Move Copy feature to illustrate some of the design intent built into this model. Once I do, a triad appears, allowing me to move the copied body in 3 directions. If I want to make more precise changes, I can input specific values for delta x, y, and z. These values are measured from the origin by default, but you can always select a different reference for the translation if needed. I'll go ahead and reduce the delta z distance by half, and then click OK so you can see how the model changes. Because of the design intent built into the model, I can easily use the copy feature to modify the scoop length. I'll edit the feature again to show you some additional options. Note that copy has been checked to create the second body. When I increase the number of copies to create a third instance, note how the same translation values apply, but are now referenced from the second instance. If I uncheck copy altogether and click OK, you can see that the original cup is simply moved rather than copied. In this case, the missing body causes several dependent features to fail, so I'll jump back in to keep the copy and move on to rotation options. With Rotate, you can still create a copy of a selected body, but instead of translation options, you're presented with rotation options. Again, you can drag the triad ring to rotate the body about a given axis, or you can define specific rotation angles. You can also select a new rotation origin, or define one in relation to the model origin. Note the preview as I rotate with the updated origin. And as you can see, I can fulfill my design intent using Rotate as well. I just have to modify the rotation origin to control the length of the scoop. Next, let's take a look at the Flex feature. This feature allows you to bend, twist, taper, or stretch existing geometry. After selecting the body for the flex, you're presented with several options, as well as some graphical feedback to make changes. Now, I'm not going to go over all of these in detail, but I will quickly illustrate each type. With bending, you adjust trim planes to bend the body about a bend axis. The axis itself can be oriented using the triad. And adjusting the trim plane positioning, lets you control the length of the flexed area. With twisting, trim planes are used to control a twist angle. The twist is created in relation to a pivot point, which is also controlled by a triad. Tapering and stretching work similarly. Checking hard edges will flex geometry using analytical surfaces such as cones, cylinders, and planes. This can sometimes create intersecting geometry, causing the model to fail. Leaving the option unchecked uses splines to create the geometry, often creating a smoother flex.